Risk averse individual, certainty equivalent, and risk premium. Suppose there is one individual and he's got this kind of utility function, right? So there is a wealth on x-axis and there is utility on y-axis. For each level of wealth, you are deriving certain level of utility. So as you guys could see that this graph is concave, right? And its slope is decreasing for the higher and higher levels of wealth. So this is what the diminishing marginal utility is. So let me just write few points, then I'll make you understand more. So one thing is that this graph has a decreasing slope, right? This you guys can decipher. So please write this. The graph of utility function, of this utility function, has a decreasing slope, right? That is, as wealth is increasing, the increase in utility is falling. That marginal utility from the higher and higher levels of wealth is falling as wealth is increasing. As wealth increases. So let us say we consider two outcomes. There is one outcome is, let's say, $100, and another outcome is, let's say, $200. And with $100, the utility which you derive is, let's say, 160. And with $200, the utility which you derive is, let's say, 280. Let me just put this, then I'll make my point. So I have $100, the utility which I get from these $100, $200, the utility which I get from these $200. Let me write these points first. 100, 200. This is the utility which you derive from 100. This is the utility which you derive from 200. Nothing much. That's fine. So naturally, the agent is preferring more wealth to less, of course. So the marginal utility is increasing in wealth, but it is diminishing. So the agent prefers more wealth to less, definitely, because when you have $200, your utility is also higher, but the marginal utility is falling. That's the point, right? So the agent prefers more wealth to less, right? But the marginal utility from wealth is decreasing, is decreasing. That is, if you get, I mean, every increased or the additional unit of wealth is giving you lesser utility than the previous utility. That's true. That's normal with everything in general. And this diminishing marginal utility is the reason for the risk aversion. I'll let you know what that is. So suppose you flip a coin. Hmm. Suppose you flip a coin and let's say if head is going to come, you're going to get $100. And of course, head is going to come with probability half. If tail is going to come, you're going to get $200. And of course, that probability is half, right? That probability is half. Fair enough. So just remember, so we are connecting this, whatever we have written now, to a gamble, to a lottery. So the expected value of the game is, of this gamble is, half probability of head getting head, you will be getting $100. probability of tail coming, that is half, you will be getting $200. So this is $150. So the expected value of this gamble is what your $150 is, right? So expected value of this gamble is, let's say, $150. So let us say it lies somewhere here, and the utility which you derive from this is this. So this is $150, and let us say the utility which you derive from this $150 is 260. This is what it is, right? Up until now there's nothing much. Okay. So when you talk about expected utility, how do you get the expected utility from them? So this is the average of the utilities of these two outcomes, 100 and 200. So let me just write what my expected utility of this gamble would be. Expected utility would be, with probability half, head is going to come. You will be getting $100, and the utility which you derive from $100 is U of 100. Probability half, tail is going to come. You'll be getting $200, and the utility which you derive from $200 is U of 200. Right? You have already plugged these points. So U of 100, I think you have assumed it to be 160, and U of 200 as 280. So it is 160, and this is 280. And once you solve this, you'll be getting 220. Right? Once you solve this, that you'll be getting 220. So expected utility, how do you just I'll use something like this, and in fact I'll use a bigger one. This looks odd, but ठीक है चलो. Okay, so expected utility from this gamble is somewhere here. Expected utility from this gamble is somewhere. So expected utility is nothing but the average of the utility levels of the two outcomes, right? According to this gamble, it is lying somewhere in the middle of the chord joining these two outcomes. So 100 U of 160, 200 U of 100 U of 100, that is one coordinate, 200 U of 200, that is another coordinate. So the line joining this and this expected utility is going to lie somewhere here, right? Somewhere in the midway of this chord. Yeah. So I can write this point, the y coordinate of this as 1 by 2 U of 100 plus 1 by 2 U of 200. I can write like this, fair enough. And what I'm getting is that this particular utility level is how much? 220. Is how much? 220. Yeah. Is how much? 220. So if you play this risky gamble, so this utility which you are getting, this 220, is the utility which you get from playing this utility gamble, this risky gamble. So if you play this risky gamble, right? It yields the utility equals to 220. So this is what the utility is. Yeah. Think about it. So you think about it. Just having $150, if you were having $150 with certainty, you were getting utility 260. But if you have to play this gamble, even though the expected value of this gamble is same as 150, the utility which you derive is less. So this is where you are not playing the gamble. This is where you are playing the gamble. So utility from not playing the gamble is more than the utility from playing the gamble. So this is what a risk averse individual is. Listen to me once more. If I give you this $150 with certainty, the utility which you derive from those $150 is 260, right? Here you are not playing a gamble. This particular point, beta. Although you don't have to mark this, but I'm just writing it for your uh, benefit. Not playing a gamble. Hmm? Here, this is the utility. Even though this 150 is same as what your sure income is. Let's say I give you $150. But 150 you're also getting from the same gamble, the expected value of this gamble. But the utility which you derive from playing the gamble is lesser. This is the utility which you get from playing a gamble, right? So, who is a risk averse individual? One who prefers no gamble to any gamble. So, he is preferring no gamble to any gamble. He doesn't want to play a gamble. That's one thing. That is one thing, right? For the risk averse individual. So, his utility from not playing a gamble is more than his utility from playing a gamble. Okay, one thing. Second thing, now ask yourself, what is that level of income or that level of wealth which is going to give you the same utility as the gamble? What is the utility which gamble is providing you? 220. Now, again, what is that level of wealth or that level of income which is going to give you the same utility level as the gamble? What is that? So 220 was the utility level. Now I'm just asking you, what level of income will give me 220 according to this utility function? Beta, this. Tuck, 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 tuck. This one. Hmm? So this level of wealth is giving me the same utility level as the gamble would have given me, right? Let us say that level of wealth is 130. Say, example. Uh, So if this was my certain income, this is the certainty equivalent of this gamble. This is the certainty equivalent of this gamble. So let me write few points so that you can write in your notes. What certain payment would yield the agent same utility? Would yield the agent same utility. So I hope you understood this. I'm just assuming, say, your W equals to, I think $130. That's what we have. This is what is called the certainty equivalence. This is what certainty equivalence is. This is what certainty equivalence is. So this is the sure amount of cash which is going to make you indifferent between playing the gamble or not playing the gamble, because you're getting the same utility. How do you understand that you are indifferent between two things when you get this the utility, when you get the same utility from two things? So if you play the gamble, you get the same utility. If you do not play the gamble, you get the same utility. That means at that particular level of wealth, you are indifferent between playing the gamble or not playing the gamble. So let me just write the definition. Certainty equivalence is the amount of sure cash that would make you indifferent between the certainty equivalent amount and the lottery. So what you are trying to say is that at this particular point, the utility which you get from certainty equivalence is equal to the expected utility of lottery. This is equal to the expected utility of the lottery. I hope you understood this better. And the difference, so beta, this guy is the expected value of the lottery. This guy is the certainty equivalence of the lottery. The difference between the two is what is called risk premium. The difference between the two is what is called the risk premium, right? So please write that. Risk premium is the amount an agent is willing to pay to avoid the risk of a fair gamble. So you're avoiding the risk, na? Because if you are getting this much level of income, uh, I mean, what you are saying is that, boss, I don't want to play the gamble. So if I play the gamble, uh, I'm getting the same utility here. And this is what my certainty equivalence amount is. So you give me rather 130, I will not play the gamble, right? So at 150, I have to play, but you give me 130, doesn't matter. I'm ready to pay you $20 so that I do not have to play the gamble. That is it. So these are the characteristics of the risk averse individual. So this is what the difference between, please write, it is the difference between the expected value of the gamble and the certainty equivalence. So in our example, it is what, beta? Your $150 minus $130, that is $20. So you're ready to pay this much, that I'm ready to pay $20. I do not want to play the gamble, right? Okay, let's do a very simple numerical example so that you understand it clearly. Suppose you are thinking to buy a lottery, and that lottery can give you $100 with probability half, or it can give you $0 with probability half, right? Your utility function is root of W. First thing, are you risk averse? I hope this should be clear to you. As you guys could see that du by dw is positive, but d2u by dw2 is negative. So it's a concave function. This function is concave in W. So definitely you are risk averse. First thing. Second, what is the certainty equivalence of this gamble? And what is the risk premium of this gamble? What is the certainty equivalence of this gamble and what is the risk premium of this gamble? So first of all, let us just find out the expected value, which is right, beta. So expected value is just 50. Expected utility is 1 by 2 root of 100 plus 1 by 2 root of 0. This will come out to be 5. So the expected and why root? Because that's what my utility function is. So this is what my expected utility from this gamble is. Fair enough. Now, what is it that I've told you about the certainty equivalence? How will you find that out? UCE should be equal to the expected utility of the gamble. Right? So if you put this certainty equivalence, if you put this amount into the utility function, you will be getting the expected utility of the gamble. Beta, what is the expected utility of the gamble? 5. And what is the utility function? Root of W. So in place of W, if I put C like this, so I'll get the value for C now. 25. Right? C is what? 25. So you are indifferent between having certainty equivalent, I mean, this amount of wealth, $25 of wealth with no risk, or a risky lottery which is going to give $50 in expectation. This one, right? So just write one line. This means that you are indifferent between having certainty equivalence of $25 with no risk. No risk because you're not playing a gamble. You're not playing a gamble. And risky lottery. You are indifferent between not playing a gamble and having $25 or playing a gamble, right? Because that playing a gamble would also give you the same utility, which this certainty equivalence amount is giving. And you're indifferent between the risky lottery which gives him expected value of the lottery equals to 50 in expectation. Avata, right? And what is the risk premium? That is just your difference between the expected value of the gamble, which is 50, and the certainty equivalence, which is 25. You with me? Right? So this is what I wanted to do in this class. Thank you, Beta.